Hey guys, today we're going to talk about similar figures as well as our scale factor. Similar figures are figures that are going to be similar or figures that are going to be the same. So when we talk about a similar figure, they have to make sure that they have the same shape but different size. So they are going to be the same shape, but the size of them may be different. So one may be smaller, one may be larger. They're not going to be equal. So if I have a small rectangle, I may have a larger rectangle. So same shape, different size. So one is larger than the other. They are also going to have corresponding sides. And what corresponding sides are is where it's going to grow or shrink by the same amount. So their corresponding sides are sides that are going to be bigger or smaller, but the same. Corresponding sides are going to grow or shrink by the same amount, or what we say multiplier. Same multiplier. So they're going to either be divided or multiplied by the same amount. And what that is that is called scale factor. So when it's going to be multiplied or divided by the same amount, that is our scale factor. So what this means is my sides are different but proportional lengths. So my sides are different, but they have a proportional length to them. For example, if I have a right triangle here, I have another right triangle that is going to be a little bit larger. So if I say this is 3, 4, and 2, let's say I say this is 6, 4, and 8. No matter which ones I look at, when I set proportional means proportion. So when I set up a proportion, it is going to be the same. So if I have 3 over 2 and 6 over 4, remember you can cross multiply. 3 times 4 is 12, 2 times 6 is 12. They are equal to each other. They are proportional. And to go from 2 to 4, I'm going to multiply by 2. To go from 3 to 6, I'm going to multiply by 2. And I could have used 4 and 8. I just you pick two sides. It doesn't matter as long as you pick the same side. And what corresponding sides are is sides that are going to be the same but on a different shape. So this is my hypotenuse for my small triangle, and this is my hypotenuse for my large triangle. So when you're looking at these, their corresponding sides are going to be in the same spot. So this is my base for my small triangle. This is my base for my large triangle. So when I look at them, sometimes you may have to turn your figure. They may not be drawn perfect or in the same exact position. However, you're going to look for corresponding sides or sides that are going to be equal to each other. So when I look at this, because I multiplied by 2, my scale factor equals times 2, or I multiplied by 2. So my scale factor is that I'm going to multiply by 2. When you have corresponding sides, it means sides that are going to be different lengths, but proportional. And so when I give you something like, let's do another set of right triangles. A large right triangle. And this time I'm just going to turn it slightly. We're going to say I have another right triangle. Remember, we're going to look for our corresponding sides. And let's say this is 6 and 10, and we're going to say this is 3 and something. So when I set this up, I'm going to look for sides that are the same. So this is my hypotenuse. It's going from one side to the other. It's not touching my right angle. So this is my other hypotenuse. So when I'm looking at those sides are the same. So this triangle, my base is here, and my base, this is turned. So I need to make sure that I look at it carefully. I want the one that's to the right of my 90 degree. If I go and turn my notebook, to the right of my 90 degree is right here. So when I set up my proportion, making sure that you have the same sides is going to be very important, because you're not going to want to do 6/10 and then put the wrong one on top. So we say this figure to that figure. So I'm going to say 6/10 equals that figure. Well, in the same spot as 6, that's my side, is going to be my 3, even though it's turned. In the same spot as 10 is my 5, so I'm going to put, is my x, so I'm going to put an x. When I look at this, cross, multiply, and divide. So 6 times x makes 6x. 10 times 3 makes 30. Divide by 6 on both sides, so I can get my variable, my x by itself. 30 divided by 6 is 5. So I'm saying that this length is 5. When I look at other figures, I'm going to sometimes have to turn my shape, but sometimes my shape is going to be inside another shape. So I may have something like this. I'm going to use a triangle again. You're not always just going to see triangles. So I'm going to have a triangle here, and I'm going to have a triangle here, and then I have a large triangle here. So I'm going to say that this is 3, this is 6. I'm going to say that this amount, oops, I went too far. This amount is 4 for right here. This amount is x. Sorry. I'm going to say that this whole amount here is going to be, from top to bottom, this whole amount is going to be 10, and this amount is x. Sorry. So I have a large triangle that has a side of 10 and 6. So I'm going to put 10 over 6. So that's my whole triangle. And then I have my small triangle, and my base for my small triangle is here. My base for my large triangle is here. So when I look at this, because my base has to be across from my base, I'm going to use 3 at the bottom here. So I'm just looking for the height of my triangle, which is located just this x portion. So this, I'm going to use x. So I'm going to do 10 times 3, which is 30. 6 times x, which makes 6x. Divide both sides by 6. X equals 5. So this amount is 5, which means this little amount would be 5 as well, if I were to break it up. But I want the whole triangle, so you need to make sure that you are careful to get your whole triangle. So looking at another example, I am going to look at, I'm going to turn my page. I'm going to look at a triangle here. Sorry about the phone, you guys. Then I'm going to do a triangle here, both of them being 90-degree angles. I'm going to say this is 1.25. I'm going to say this is 1.5. I'm going to say this is 180. And I'm going to say this is x. So once again, you need to make sure that you have sides that are going to be equal to each other, that are going to be the same, that you're going to end up using on both sides. So when I look at this, my base of my triangle, even though this one's been turned, is 1.5, and then the base of this one is 180. The sides for my triangle are here. The sides for my triangle are here. So when I look at this, I'm going to set it up. I'm going to say this to that. So I'm going to say 1.25 and 1.5. Across from 1.25, I've got to keep it the same size. So I'm going to say x over 180. Cross, multiply, and divide. 1.25 times 180 is going to give me, I'm going to give you a second to try it. Pause the video if you'd like. And multiply, divide, set it up. X is going to equal 150 when you're done. Hopefully you guys were able to follow along with these examples. You will have another video coming up with a couple more examples. If you do not understand something, remember, please send an email. I will be attaching a couple other things for this week. Hopefully you understand them. Have a good rest of your day.